Hi guys, and welcome to Journey Through to the Centre of the Earth. This is activity 1 for year 8, where we're going to be looking at minerals. Okay, so what is a mineral? Well, first thing is that we need to identify the difference between rocks and minerals. Now, rocks are made up of minerals, not the other way around. So within a rock, you're going to have a variety of different minerals. Now, there are about 5,000 known minerals on this planet, and from that, in certain quantities and certain concentrations, you'll get different types of rocks. Now, we can identify these minerals using 7 main tests. Well, we're going to look at 7 main tests here, although you'll find that there are other tests that geologists use to identify minerals. But the 7 ones that we're going to look at here are looking at the colour, the luster, the structure, the cleavage, the streak test, hardness and density of the minerals. Now we will identify each of these as we go through the course, through the next couple of slides, but do be aware that there are others that geologists will use. As well as this, we know that we have some minerals that come in the form of what we call gemstones. Now basically a gemstone is more often than not a mineral which is quite rare, hence the expense, and these can be cut and polished and then be put into jewellery. Now you'll be aware that this is big business, and as a result, by finding specific types of gemstones, you can actually get different types of jewellery, different colours, different shapes, and yeah, as I say, the big business in the jewellery market. Okay, so let's look at some of the minerals that we'll have in school. The main ones here are the ones that we use at St Hilda's. We've got hematite, feldspar, calcite, galena, talc, pyrite, magnetite, kaolinite, azurite, malachite, biotite, and quartz. However, there are many more, but these are the ones that we use here. Now, the pictures, although you may think, oh, they'll all look like this, they don't. Some will vary depending on where you take them in, where you take the mineral out in the world. So then they won't always be like you see in the pictures here. Okay, so let's have a look at some of the tests. Well, the first test that we've got is the colour. Now you can see from these 3 examples here, we've got 3 different colours, and each mineral has its own specific colour. The type of colour will vary depending, as I say, the area in the world that you take the mineral. But you can see here, calcite's got this sort of pinky hue, malachite's got a green colour, and azurite has got that beautiful blue and green linked in. And you can link that with the idea of the azures, and those are the colours which sort of link with that area. We've then got luster. Now, luster looks at how well the crystals which make up the mineral reflect light. Now, in some cases, they reflect light really well, so we've got a high, shiny luster, and in some cases, they don't. So as a result, we get a dull luster. For example, talc in the left here, made up of very fine crystals, doesn't reflect light particularly well, so you would consider talc as a dull luster. Pyrite in the middle, also known as fool's gold, will reflect light really well, so it's got a shiny luster. And galena, you can see the beautiful crystals which are formed there, they will reflect light really well, and so we would say that's got a shiny luster. The next one we're going to look at is the structure. Now, I've already mentioned that some of these minerals have crystals, and the structure looks at the type of crystals that you can generate. Now, in your classes, you will have looked at crystal formation, and depending on how a mineral is allowed to cool will determine how well that structure forms. Now, crystals are very geometric, and more often than not, you'll get some beautiful, nice shapes. And if you look at galena in the luster diagram, you can see you get that beautiful square. But by knowing and identifying the types of crystals that are formed, that will give you an indication of the type of structure and hence the mineral that you're dealing with. Quartz, as we well know, has got a very, can be cut down and have very nice crystals which are very smooth. Okay, next one is cleavage. Now, cleavage looks at how well the mineral can be split, how well the crystals are put together, and it works on planes. Now, if you look at muscovite mica on the right-hand side here, you can see that it's got very defined layers, and as a result, you can see in the first photo that the penknife can actually cut through those layers. Now that cutting through is what we call cleavage. Now in some cases that cleavage is very easy, it's very, very soft. As you can see, you can do it with a penknife. Sometimes it takes a lot more effort and force to produce that, that cleavage. Some minerals won't have any cleavage at all because of the way the crystals are formed, and then you'll get very, very jagged edges. So the cleavage test will look at how well it is able to be split. We go on to the streak test. Now the streak test is often done on an unglazed tile, and it looks at when you scratch the mineral across the unglazed white tile, it looks at the color of the powder which is generated. Now if you look at the three photos that you've got here, we've got galena. Galena is putting that sort of grey color. Then we've got magnetite, has a sort of browny grey color. Then in the bottom left, we've got hematite on the left. Now, although hematite looks black, you can see it's coming out with brown, and malachite on the right is coming out with a green color. So it's looking at the powder which is generated when it's streaked across an unglazed tile. So that's another test. And if you go onto the web and put in streak tests, you'll see the various different colors which each mineral can generate. Now, combining all of these tests together will give you a good indicator as to what mineral you're dealing with. Now, what else have we got? We've also got hardness. Now, this looks at the ability for one mineral to scratch another. Now, some are very, very soft and some are very, very hard. Now, the hardest one is diamond. It's a very, very strong mineral made up of the pure atoms of carbon, and they're combined in such a way that it's one of the hardest minerals on the planet. Now, diamond will cut virtually anything, it will scratch anything. Talc, on the other hand, is incredibly soft, so you try and cut diamond with talc, it's not going to happen. Now, there's a special scale called the Mohs scale, which will indicate how well an element will scratch another element. And you can see here that, for example, it gives you an idea that talc is scrapable with your fingernail, and it will also look at how well a mineral will scratch something higher or lower in the table. For example, if we looked at quartz, which has a hardness of 7, it will scratch anything below it. From 6 down to 1, quartz will scratch them. However, if I took gypsum and tried to scratch it on topaz, which is number 8, you'll find that doesn't work. Gypsum is far too soft. Quartz will not scratch topaz because it's softer than the topaz. However, it will work in the opposite direction. So the Mohs test looks at how well one element scratches another. And the final test that we look at is density, and literally that's how well compacted the particles are. Now, you will have done this in your chemistry where you can actually drop a certain mass of a mineral into some water, and you will see the volume that it takes up, and dividing the mass by the volume will give you an idea of its density. Okay, so that gives you a rough insight into minerals. We now know that minerals make up rocks, and we've now identified the 7 main tests that we use here at St. Hilda's for identifying our minerals. I hope you found this useful, and join me again for the next activity. See you soon.